Hi everyone. Today my group and I are going to present about Reed-Solomon code. Okay. These are my group members. The first one is Yuvegan Rao. Second one is Vinod Tharshan. Third one is Magdelene, and fourth one myself, Sambavi. Okay. Firstly, for introduction, Reed-Solomon codes are the codes that was introduced by Erwin Hezri and Gustav Solomon. Reed-Solomon code is a subclass of non-binary BCH codes. The encoder of Reed-Solomon codes differs from a binary encoder in that it operates on multiple bits rather than individual bits. So basically, Reed-Solomon codes help in recovering corrupted messages that are being transferred over a network. In Reed-Solomon codes, we have encoder and decoder. Reed-Solomon codes encoder receives data, and before transferring it over the noisy network, it adds some parity bits with our original data bits. On the other hand, we have a Reed-Solomon codes decoder that detects messages and recovers them from error.
Hi, Doctor. Wishing you a good day. My name is Yuvegan Rao. My student ID will be DN 2012. So I'm going to be explaining about the objectives of our project. So the purpose of Reed Solomon, also known as RS, encoder and decoder, is to correct burst errors in digital communication systems, broadcasting systems, and also digital storage devices using the technique of forward error correction. So this following slide is about the study background. So basically, Reed-Solomon codes were developed in 1960 by Irving S. Reed and Gustav Solomon. So the original encoding scheme used a variable polynomial based on the message to be encoded. There are now two main types of Reed-Solomon codes. One of it is the original scheme, and also the other one is BCH encoding. Reed-Solomon codes were developed by Wesley Peterson in 1961 and were first implemented in the Voyager program in 1977. Reed-Solomon codes are being slowly replaced by Bose Chowdhury Hockengham BCH codes. They are used in digital video broadcasting, also known as DVB, standard DVB-S in conjunction with convolutional inner code, but not LDPC. That's all from me. We'll move on to the next slide. Thank you.
Greetings, Doctor. My name is Vinod Shiva. I'm representing my Group 8 for the BDP for digital communication to explain the analysis of Reed-Solomon code. So, parameters of Reed-Solomon code is used to encode m-bit symbols, where the block length is given by 2m-1 symbols. In Reed-Solomon codes, message given is by n-2t in bracket where t equals to number of error corrected. So following by the parity check, size is given by n-k or 2t symbols, and following by minimum distance and message size of k byte. So under the analysis of Reed-Solomon codes, there is a general function. So the general function of Reed-Solomon codes, the generator function is generated using a special polynomial. In Reed-Solomon codes, all valid code words are exactly divisible by generator polynomial. The generator function is given by, this is the equation for the generator function. So next is encoding of Reed-Solomon code. So for the encoding, we perform encoding in Reed-Solomon codes with the following method. That is, consider a Reed-Solomon code with parameters n, with block size, k for the message size, q for the symbol size in bits. For encoding, we encode the message as a polynomial and then multiply it with a code generator polynomial. So following by the equation where the gx equals to, these are the equation, then we map the message vector, and then polynomial can be used Lagrange interpolation, and then sender calculates the equation and then sends over the coefficients of s X. So next is the decoding of Reed-Solomon code. So for the decoding part, at the receiver and we perform the following method. That is, the receiver receives at the receiver end. If Sx equals to Rx, then Rx over Gx has no reminder. So if it has a reminder, then Rx equals to Px times Gx plus Ex, where Ex is the error polynomial. That's all from me, doctor. The following parts of advantages and disadvantages of this Solomon code will be explained by my fellow groupmates. Thank you.
Okay, for the advantages, the first point is it has the highest efficient use of redundancy, and for the second point, it is possible to adjust block length and symbol size in Reed Solomon codes, and for the third, it provides a wide range of code rates, and for the last point, in Reed Solomon codes, there are efficient decoding techniques available. Okay, for the disadvantages, they have two points, which are the first one for BPSK modulation schemes. Reed Solomon code does not perform well in comparison with VCH code. And for the second point, in Reed Solomon code, the bit error ratio is not satisfying in comparison with VCH codes. Okay, for the applications, they have 6 points, which are storage devices like CDs, DVD, and etc. And for the second point, which are the wireless or mobile communication for data transfer. For the third point is satellite communication, and the fourth one is digital TV, and the fifth is high-speed modems, and the last one is barcode, which is QR code. As a conclusion, we have examined Reed-Solomon RS codes as a powerful class of non-binary block codes, particularly useful for correcting burst errors. They can be configured with long block lengths in bits with less decoding time than other codes of similar lengths. This is because the decoder logic works with symbol-based rather than bit-based arithmetic.